80% engineers are unemployed. But that theory knowledge we never used practically. Knowledge of CNC machine vitals for soon to be engineers. So that is why we decided to build a CNC operated milling machine as a final year project. This is our concept 2. Welcome back to the channel everyone. I hope you guys are doing absolutely fine. I'm just waiting at home to let the parts arrive for our final year project. Today is 25th March 2020, and even though the colleges are closed and all our exams were done on MCQs, I still started doing a final year project. So I have ordered the parts from Roboru, 3D printing and Amazon. So basically what I have done is our final year project is more of a assembly kind of project. So I knew that because of the COVID and Corona, maybe the colleges will be closed for a very long time and I will not get the chance to work on the final year project if I do something that is more of a manufacturing and kind of difficult to be done. So my project is very assembly related and programming related, so that it is possible to be made in this scenario. And I'll just give a quick update on how our final year project is, what we are doing, and till where has the progress come. Like, even though we are at home, the progress has been made, a lot of progress has been made, and that's what we're going to talk about today. So for every project in engineering, you have to make a presentation and a synopsis report. So this was our presentation. So our objective is to design an affordable mini CNC milling machine which can do operations of milling, cutting and drilling. So our plan is to use a GRBL open source software combined with Arduino Uno. So using this, we want to build a machine that can take G codes as an input and output via the Arduino to control the stepper motors. So we want to make a machine that can do machining in 3D and 2D depending on the requirements. So this is just an intro of what a milling machine is. So milling machine is used in all industries: the metal industry, the pharma industry, the amputation industry, the plastic industry. Milling machine is used everywhere. And in 1960, computer numerical control was added to the milling machine. Because of this, the flexibility and degree of complex parts capable of machining were improved. So this was a study which was done by the Times of India, Dainik Jagran, the Hindu, the Chronic, Deccan Chronic. So what it states is 80% engineers are unemployed. This is because India is facing a massive skill gap problem with hundreds of engineers graduating every year, but only a few possessing the skills required in the industry now. So almost all development taking across all sectors require machining of metal components, and computer numerical control is used for this task, which makes learning and gaining knowledge of CNC machine vitals for soon to be engineers. So even our college had a CNC machine, but what was happening was it was a CNC lathe machine, and the only time we were getting the machine to use was when there were practicals. So if there were practicals like you have to machine this part, you have to produce this part, you have to bring this part to this dimension, in such scenarios only we were getting the machine to use. And the only CNC lathe machine was like the only machine in college. So if it got damaged by chance, if we were using it for our personal projects and by chance the programming got wrong and it got damaged, so that will be a big problem for the college. That's why they were not letting us use that machine. Now the problem is that engineering colleges cannot also give such expensive machines to the students. So now a CNC milling machine will cost from 1 lakh to 10 lakhs, and the metal cutting ones. So it is not feasible for colleges to give it to students directly who have very less knowledge about the CNC machining, right? So what is happening is the colleges are not letting the students work on their own projects with the machines, because Obviously, there is a chance of damaging the machine if the programming goes wrong and if the student does not know how to handle it. And that is why we decided to make a project. So, problem statement. So, where the technologies are updating, new improvements in machining process are taking place. So, it is very important that engineering students also learn these new technologies, not just in textbooks, but with hands on experience, without the fear of huge financial losses in case of failure or wrong usage. Therefore, a relatively affordable and flexible solution is required for students to learn, experiment, and practice using new technologies like CNC. So this is the methodology. So methodology is how you are going to make the machine and in which steps did your thinking take place. So first was the need or aim. Need or aim is to understand theory concepts better, make a affordable mini CNC milling machine so that students can learn and experiment. Then is the synthesis of mechanisms. So once your problem statement is done, you have to kind of identify what mechanisms you will need. So if this is your problem statement and you have to design mechanisms to solve this problem statement. Now the mechanisms that we are going to need is 70 by 60 aluminum T-slot frame with linear sliding bearings and polystyrene for motor attachments and couplings. Now we are using polystyrene. That is because first we were planning to use 3D printing parts. So the 3D printed parts are made of ABS. Now 3D printed parts were getting very costly. So the whole budget was going for the 3D printed parts. Now we try to do it in metal. Now even if you do it in metal, the machine becomes heavier, there's rusting, and the price increases even more. So the most affordable solution that we found out for our machine was polystyrene. Now this idea came to my mind when I was looking at a kitchen board. So our kitchen board is made up of polystyrene material, which is very strong and can take a lot of load. That is why we are using this polystyrene material. Then is analysis of forces. So once your mechanisms are ready, then you have to figure out what forces you will need to solve this need or aim. So the analysis of forces, we will need a NEMA 17 4.2 kg per centimeter stepper motor. This is the stepper motor which will move the X, Y and Z axis on our CNC machine. So we are going to use aluminum and polystyrene for parts, and attachments will be done by N5 bolts and T-slot nuts. Then is the design of elements. So design of elements is how your machine is going to be, what dimensions will it be able to machine in, and the details of what the capabilities of that machine will be. So our machine will have a 70 by 60 centimeter base and 70 centimeter height of tool travel, which is very high. Then is modification. In case the parts do not fit, we'll have to do some changes, and changes will be required as per manufacturing. Detailed drawings I will give it in the next slide. And then there is the production. So in production, first we'll have to assemble the base, then we have to join the X-axis motor, install the threaded shaft, assembly of sliding column, installing the belt pulleys, installing the Y-axis threaded shaft, installing the belt pulley for the Y-axis movement, installing the work table, Z-axis motor, installing all the Arduino boards and drivers, wiring, programming trials, problem solving and finalization. So this is how we are going to go about to make this machine. So this is a block diagram. Now a block diagram is a basic way to explain what the machine is and how the machine is going to control the motions and do the task. So we will give G codes via a laptop to a Arduino board, and this Arduino board will be loaded with a firmware called as the GRBL. Now this GRBL is an open source software which we will load into the Arduino board to tell it that we are now going to play with G codes to run a machine. Next is we will use a Arduino CNC shield. This shield will go on top of this, and this shield will tell the Arduino board that we are going to play with GRBL G codes and we are going to run stepper motors. So this is how it all comes together. So when you are designing a machine, you have to make many conceptual drawings to figure out which is the best possible way to do the work effectively. Now this is the concept one which I designed. This is made up of, has a wooden base, has wooden columns, and the tool post is also made up of wood. The work table is also wooden. Now, this machine is also made according to the dimensions that we plan to make. Now, I'll explain it to you in a very simple way. Now, this base has a DC motor over here. It is connected to a threaded shaft which has nuts in the middle, which are connected to this work table. So when this motor rotates, it will rotate this threaded shaft. Because of that, the work table will move forward and behind. Then this motor is connected on the column. This also has a threaded shaft and nuts. So when this motor rotates, it will move the tool post left and right. So because then the tool post will move left and right, the work table will move front and back. Now behind this tool post there is another DC motor which has a threaded shaft that goes behind it. So what will happen is when this motor will rotate, it will move the tool post up and down. So that will establish a front and back, left and right, and up and down movements. That will enable us to make 3D and 2D objects. This is our concept 2. Then now this machine is made up totally of aluminum. The parts which are used to join the aluminum platform are made up of polystyrene. So there is no rust issues. The machine will last ever longer. The machine will last longer, and this is made up on the same concept as this one. So this has aluminum T-slot 20 by 20 extrusions all the way around over here on the top and for the base too. So the concept working is same. There is a motor over here. This is the x-axis motor. It is using a coupling. It is connected to a threaded shaft. Here are the rotational bearings. Now this shaft will rotate. It is connected via a belt to this column. Okay, this is connected via belt to this column. So when this motor will rotate, it will slide the column front and back. Okay, next is this is the y-axis motor. The y-axis motor is also coupled to a threaded shaft which goes into rotational bearings. Now this is connected to this column over here. Now when this motor will rotate, this shaft will rotate and it will slide this column in up and down direction. Now on this column there is another motor which will be used for the left and right movement of the tool post. Now this motor also has a belt which is connected to the tool post, which will slide the tool post left and right. And here is our work table. The work table will have 3-jaw chuck clamps or a 4-jaw chuck clamp, depending on once the machine is done and once we get to see it, depending on that we will decide how we are going to do the jig and fixtures for the work table. Here there are linear bearings for easy sliding of the columns. So working I have already explained it to you on the diagram, so I'm just going to skip that up. So advantages of this project is that it is a perfect mini machine to demonstrate components of a CNC milling machine to the students. You can build 2D or 3D parts. You can build complex parts with high accuracy, rapid prototyping for projects. The G codes and M codes which are used in industry for CNC operation can be learnt, taught and tested on our machine. Real life operations of CNC machine can be demonstrated without the fear of huge financial losses. Parts required for micro project, final year project can be built. All the functions and everything about CNC machine can be taught on our machine and it can be used by small scale workshop and practical labs. So cost and part analysis, this is the cost and part analysis. Now this has each and every nut and bolt, motor, aluminum T-slot, everything that we will require to build this machine, and the total is coming to around 11,100, which is a very less price actually, because milling machines cost about a lakh, and such demonstration educational purpose machines also start above 50k. So this is a very ambitious effort we are trying to do to make this machine in under 11,000 rupees. Plan of execution. Conclusion. So building a mini CNC milling machine will give team members a lot of practical knowledge and technological exposure. By working on this project, we will understand GRBL, G code programming. The machine will be useful to college and workshop, and not only to demonstrate but also to build future parts. The machine increases scope of the engineering students which will come into Yashwantharao Bhosle College, and that is one thing. So you also have to make a synopsis report of your project. So this is our synopsis report. It is of 28 pages. It includes all the detailed information that I told to you in the presentation, but here it is in a much detailed format, which in which each and every little point is more elaborated and more deeply thought about.